All, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to discuss about different type of registers which we are going to have. And this is a part of RISC-V processor design series where first we are going to discuss some prerequisites like which is related to computer organization and architecture. Like what are all the things which are needed so that we can seamlessly design a RISC-V processor. For that, we need to know some prerequisites, right? Now, yeah. So in this particular video, let's try to understand what do you mean by MAR, MDR, IR, ALU, accumulator, and interrupt, right? So this particular diagram, if you carefully observe, we have different kind of registers. One is program counter and another is memory address register and followed by memory data register and instruction register and control unit. And this is our main memory and this is ALU and accumulator. Let's try to understand these components in great detail and let's come back to this animation and let's try to understand what is happening over here, right? So the very first thing which I'm going to have is an address register. Now, what do you mean by an address register? See, let's say if some data is present inside your memory and let's say if your processor wants to access that particular memory, how the processor is going to access your memory. If you have tried working with your random access memory using your Verilog, it's a simple kind of project where you are going to issue the address which you want to write or read from that particular address location, and from that you're going to get your data, right? So same here also. Processor is not going to directly provide the memory like whatever the related address, it is not going to give it to the memory, right? It is basically going to issue the address to some register which is known as address register, memory address register. So processor, whatever the data it wants to write or whatever the data it wants to read, that particular address it is going to store in a register which is known as memory address register, and this is what it is. So let me pause this animation. Yeah, this is one second, let me show you. Yeah, this is what memory address register is. So over here, your processor is going to store the address which it wants to, from which it wants to write or read from it. And this memory address register is going to provide that particular address onto the address bus to this particular memory so that your processor is going to write or read from this particular memory. So this is how your processor is going to store the address into memory address register. And this memory address register is going to issue the address onto this address bus and further to this random access memory. Now, this is what it is written over here. So, an address register, it is a special purpose register inside the CPU that is going to hold the memory address, and it is going to tell the system where in memory to read from or write to. And the most important one is our memory address register. Now, this memory address register, whenever the CPU wants to access the memory, it is going to first load the target address into MAR. That is what this animation is also showing. Whatever the address it wants to read or write, it is going to load that particular address into this MAR, and from that MAR is going to MAR is going to basically push that particular data onto the address bus, right? Now, okay, address has been issued to our random access memory, and now random access memory knows like which particular address the data is present. Now, from how if you want to read or write using which particular bus you are going to read or write, or where exactly the data is being stored, if you are going to read the data or if you want to write the data, from where you are going to write the data. So for that we have one more register which is known as memory data register. So you can see from this animation, so after providing this address from this memory address bus to this address bus, we are going to use another register which is known as memory data register. So the whatever the data the processor wants to write into this particular memory, or whatever the data which the processor wants to read from this memory, it will be stored inside this particular register which is known as memory data register. Now, using this memory data register, this particular memory data register will be sending the data onto this particular data bus, or will be reading the data from this memory via the data bus. So this is where the data is being stored after processor provided the address to this memory address register. So that is what this memory data register. So it works with a pair of MAR. MAR says where and the MDR says what. So after the MAR selects a particular location, the data travels over the data bus into the MDR and CPU picks it from particular there, right? So this is how memory data register is going to work with your MIR. Now, there is one more kind of register which is known as program counter. Now, what do you mean by program counter? Let us see with this animation. Yeah. So this is your program counter. So your program counter is another address register, but it is specifically for instructions. So it always holds the address of the next instruction to execute. And after each instruction, the PC automatically increments. So for example, if I'm going previous session we have seen, like we have two kind of architectures like von Neumann and Harvard architecture. Let's say if the data memory and instruction memory are having the same memory location, like we are going to refer to the von Neumann architecture where data and instructions are stored inside the same memory. Like let's say suppose if the instructions are stored inside this memory, the user or the processor, how it is going to know like next instruction what it should fetch. So that particular address will be given by this program counter. Basically, program counter is going to tell you which instruction should be fetched in the next cycle. That is being decided by your program counter, which is going to tell you which particular instruction is to be executed, right? So here the example. So when you hear the CPU fetched instruction at this particular address, the PC had 004 in it, which got copied into the MAR to trigger the actual memory read. So what is going to happen? What particular instruction should be fetched from this particular memory program counter register is going to decide. That particular address will be given to this MAR, and from this MAR it is going to be given to this address bus, and from this bus it is going to given to this RAM. So this is how program counter is going to decide which particular instruction to be fetched, right? So that was about your address register, and that is memory address register, program counter, and memory data register. Yeah, this particular diagram is basically depicting what is happening over here. Let's try to understand again. So program counter is going to hold the next instruction address. It is basically holding the next instruction address, and memory address register is basically going to send the address to the bus. Okay, program counter is telling the memory address to provide which particular address, and it is providing. Memory address register is providing the actual address onto the address bus, and we are going to basically select a particular address, and from this particular address, if we want to select this particular instruction or this particular data, we are going to fetch this particular data and we are going to hold it using this memory data register. Or let's say if I want to write something into this particular location, I'm going to store the data first into this memory data register, and from this I'm going to write it into my main memory. So this is how this three registers are going to work with each other, right? Now, so yeah, this is the step-by-step explanation. So first the CPU is going to decide it needs data, let's say at 002, right? So let's say if I want to read the data from this 002. So what is going to happen? It is basically going to load 002 into the memory address register. So CPU is going to load the particular address which is nothing but 002. Now this 002 is going to be put it on the address bus, and after that RAM is going to decode the address, and it is going to select that particular row, and the data at that particular address will be traveled into our data register MDR via this data bus, right? And next CPU is going to read it from the MDR and it is going to process it. So this is how you are going to read a particular data. Now, for a 16-bit memory address register, we are going to have the accessible memory is 2 power 16, which is 64 kilobyte. And for 20-bit MAR, we are going to have 2 power 20 is 1 megabyte. And for 32, we are going to have 4 GB. And 64-bit, it is going to have 2 power 64, but it is theoretical, right? So these are the accessible addressable memory. Next we have other kind of registers. One of that particular register is accumulator. Now, with this help of animation, let's try to understand where is accumulator and what is accumulator doing. Yeah. So if you carefully observe the data flow, whatever the operations which were performed by our arithmetic logic unit, basically arithmetic logic unit is a kind of component which is going to perform all the arithmetic operations, logical operations, multiplication operations and all. And the result of that particular operations, if it needed to be stored, we are going to use other kind of register which is known as accumulator. So in this accumulator, we are going to store the results of this ALU. So this is where you can think of using an accumulator. So that is what it is written over here. It's kind of a CPU scratchpad. The ALU always drops its results here first, Like adding two numbers, the sum is going to stored into the ACC, or the AND of two values, the results land in the ACC. So it's most used register in the entire CPU, right? And next is instruction register. As I've told you previously, this particular instruction register is going to basically hold the particular instructions. It is going to hold the current instruction being executed, and it has different kind of parts like opcode and operand and all that we are going to discuss a lot, right? And this is where instruction register is going to hold the instructions, and it is being basically controlled by your control unit, right? And this instruction register is going to hold like what kind of instruction is presently happening, whether it is an add operation or multiplication or subtraction, or right? Yes. Next is interrupt register. So we kind of have some kind of interrupt registers. Like for example, if CPU is doing some particular task, and if you want to like interrupt the CPU operation, we can have the interrupt signals. Those particular interrupt signals can be having inside your interrupt register. And let's say suppose if I want to and also have some kind of register which is known as output register, which is basically the last stop before the data leaves the CPU to reach a screen or port or any particular external device. Like, for example, if my processor has received a particular data from the main memory and it should be given to any other component, then I can store this particular data into my output register, which kind of acting like a buffer and all, right? So these are the different kind of memory registers or data registers which I can think of. I'm going to use commonly. One is memory data register, accumulator, interrupt register, instruction register, and output register. So that's about this particular session where we have discussed about different kind of registers which we are going to use a lot in our processor, right? Yes. So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.